Hello friends, today we are going to talk on topic nuclear fusion. What is nuclear fusion? Nuclear fusion is a process by which two or more atomic nuclei join together or fuse to form single heavier nuclei. This reaction releases a tremendous amount of energy as the total mass of resulting nucleus is less than sum of masses of the original nuclei. The difference in mass is converted into energy according to Einstein equation E is equal to mc square. Nuclear fusion is a process that powers the sun and other stars. In the sun, hydrogen nuclei fuse together to form helium nuclei, releasing a vast amount of energy in the process. The energy is then radiated into space in the form of light and heat. Nuclear fusion is also being investigated as a potential source of energy on Earth. Fusion reactors would be able to produce large amounts of clean, safe energy without producing greenhouse gases or other pollutants. However, fusion is a very challenging process to control, and scientists have not yet been able to build a fusion reactor that produces more energy than it consumes. There are two main types of nuclear fusion: magnetic confinement fusion and inertial confinement fusion. Magnetic confinement fusion uses magnetic fields to trap and confine a plasma, which is hot, charged gas made up of positive ions and free-moving electrons. The plasma is heated to extremely high temperature, which allows the nuclei to fuse together. Inertial confinement fusion uses laser or particle beams to heat and compress a small pellet of fuel to extremely high temperature and densities. This causes the nuclei in the fuel to fuse together. Both magnetic and confinement fusion and inertial confinement fusion are still under development, but there has been significant progress in recent years. Scientists are now hopeful that fusion reactors could be commercially viable within the next few decades. Benefits of nuclear fusion. Nuclear fusion has a number of potential benefits over other forms of energy generation, including other energies. It is a very efficient source of energy. Fusion reaction produces much more energy per unit mass of fuel than any other type of energy reaction, including fission. It is a clean source of energy. Fusion reaction do not produce any greenhouse gases or other pollutants. It is a safe source of energy. Fusion reactors are not susceptible to meltdown or other accidents that occur with nuclear fusion reactors. It is a sustainable source of energy. Fusion fuel, deuterium and tritium is abundant on Earth and could potentially supply humanity with energy for millions of years. Challenges of nuclear fusion. Despite the many potential benefits of nuclear fusion, there are also a number of challenges that need to be overcome before fusion reactors can become commercially viable. These challenges include achieving and maintaining extremely high temperature and pressure required for fusion to occur, confining the plasma for a long period of time for fusion reaction to take place, developing material that can withstand harsh conditions inside the fusion reactor, making fusion reactors more economically competitive with the other form of energy generation. Despite the challenges, the scientists are optimistic that fusion reactors can be developed and deployed within the next few decades. Fusion has potential to revolutionize the way we generate energy and power our world. How fusion is done commercially? Commercial fusion is still in its early stages of development, but there are a number of companies working to build commercial fusion reactors. These companies are using the variety of approaches, but they all share the same goal to develop a fusion reactor that can produce electricity at a competitive cost. One of the most promising approach to commercial fusion is to use tokamak reactors. Tokamak are duff-nut-shaped devices that use magnetic field to confine a plasma. Tokamaks have been around for decades and they have shown to be capable of producing fusion reactions. However, tokamak have not yet been able to produce energy that they consume. A number of companies are developing tokamak reactors for commercial use. One of the most advanced projects is ITER, an international collaboration to build a tokamak reactor in France. ITER is expected to begin operation in early 2030s and will be largest tokamak reactor ever built. Another approach to commercial fusion is use of stellarator reactors. Stellarator reactors are similar to tokamaks, but they use a different magnetic field confinements or field configuration to confine the plasma. Stellarators have the potential to be more efficient than tokamaks, but they are also more complex. A number of companies are developing stellarator reactors for commercial use. One of the most advanced projects is in Wendelstein 7X stellarator in Germany. The Wendelstein 7X is the largest stellarator reactors in the world, and it has already achieved some promising results. In addition to tokamaks and stellarators, there are a number of other approaches to commercial fusion being developed. These include inertial confinement fusion (ICF) and magnetized target fusion (MTF). ICF uses powerful lasers or particle beams to heat and compress the small pellet of fuel to extremely high temperature and densities. MTF uses a combination of magnetic fields and laser to confine and heat a plasma. A number of companies are developing ICF and MTF reactors for commercial use. One of the most advanced projects in the NIF National Ignition Facility in California. The NIF is the largest laser facility in the world, and it has already achieved some promising results with ICF. Timeline for commercial fusion. It is difficult to predict when commercial fusion will be a reality. However, many experts believe that fusion reactors could be commercially viable within the next few decades. Some companies are predicting that they will be able to deliver electricity to the grid from fusion reactors before 2035. The development of commercial fusion is being driven by a number of factors, including the need for clean, sustainable energy source. Fusion has the potential to provide a virtually limitless source of clean energy without producing greenhouse gases or other pollutants. Advances in material science and engineering. New materials are being developed that can withstand a harsh condition inside a fusion reactor. Increased investment in fusion research and development. Government and private investors are investing more money in fusion research and development than ever before. Conclusion. Commercial fusion is still in its early stages of development, but there is significant progress being made. A number of companies are developing different approaches to commercial fusion reactors, and they are all making promising progress. If the current trend continues, fusion reactors could be commercially viable within the next few decades. How power generation can be done, or how power can be generated with fusion technology? Fusion technology can be used to generate power by using heat produced by a fusion reaction to create steam, which can then be used to drive a turbine to generate electricity. This is the same process that is used in conventional power plants, but fusion reactors would be much more efficient and would not produce any greenhouse gases or other pollutants. Here are some more detailed overview of the process. Fuel, deuterium and tritium, is injected into the core of fusion reactor. The fuel is heated to extremely high temperature, over 100 million degrees Celsius, and compressed to very high densities. This causes the nuclei of the fuel atoms to fuse together, releasing a tremendous amount of energy. The energy released from the fusion reaction heats a coolant, such as water or helium, that flows through the reactor core. The heated coolant is then used to generate steam, which drives a turbine to generate electricity. Fusion reactors are still under development, but scientists have already made significant progress. In 2021, researchers at the National Ignition Facility (NIF) in California achieved a major breakthrough by producing more energy from fusion reaction that was used to create the reaction. This was the first time that this had ever been achieved. While there are still challenges that need to be overcome before fusion reactors can be commercially viable, scientists are optimistic that this will happen within the next few decades. Fusion has the potential to revolutionize the way we generate energy and power our world. Here are some of the potential benefits of using fusion technology to generate power. Efficiency. Fusion reactions are much more efficient than conventional energy sources such as coal and natural gas. This means that fusion reactors will be able to produce more electricity per unit of fuel than conventional power plants. Cleanliness. Fusion reactors do not produce any greenhouse gases or other pollutants. This means that fusion reactors will be a much cleaner source of energy than conventional power plants. Safety. Fusion reactors are inherently safe. There is no risk or meltdown or other accident that could release radioactive material into the environment. Sustainability. Fusion fuel, deuterium and tritium is abundant on Earth and could potentially supply humanity with energy of millions of years. Overall, fusion technology has the potential to provide a safe, clean and sustainable source of energy for the future. How much power can be generated with fusion technology? The amount of power that can be generated with fusion technology is virtually limitless. Fusion reaction produce about 4 million times more energy per kilogram of fuel than burning the coal, oil or natural gas. This means that relatively small amount of fusion fuel could be used to generate a vast amount of electricity. For example, a single fusion reactor could produce enough electricity to power a city of 1 million people. And because fusion reactors do not produce any greenhouse gases or other pollutants, they could help us to mitigate the effects of climate change. However, fusion reactors are still under development and it is difficult to say exactly how much power they will be able to generate in the future. Some experts believe that fusion reactors could be commercially viable within the next few decades, while others believe that it may take longer. Here are some examples of potential power output of different fusion reactor designs. ITER 500 megawatts, Demo 2000 megawatts, Proto 10,000 megawatts, commercial fusion reactor 1000 to 5000 megawatts. There are few examples. These are few examples, and actual power of output of the fusion reactor will depend on the design and size. However, it is clear that fusion technology has the potential to generate vast amount of power. Once fusion reactors are commercially viable, they could play a major role in meeting our global energy needs. They could help us reduce our reliance on fossil fuels and transition to clean energy future. What is advantages and disadvantages of fusion energy technology? Advantages of fusion energy technology. Clean. Fusion reactions do not produce any greenhouse gases or other pollutants, making them a very clean source of energy. Safe. Fusion reactors are inherently safe. There is no risk of meltdown or other accident that could release radioactive material into the environment. Sustainable. Fusion fuel, deuterium and tritium is abundant on Earth and could potentially supply humanity with energy for millions of years. Efficient. Fusion reactions are much more efficient than conventional energy sources such as coal and natural gas. This means that fusion reactors would be able to produce more electricity per unit of fuel than conventional power plants. Disadvantage of fusion energy technology. Technical challenges. Fusion reactors are very complex and difficult to build. Scientists are working on overcoming the number of technical challenges before the fusion reactors can become commercially viable. Cost. Fusion reactors are expected to be very expensive to build and operate. It is not yet clear whether fusion energy will be able to compete with other forms of energy on cost. Radioactivity. Fusion reactors do not produce any radioactivity waste, but it is much less than the amount of radioactive waste produced by the nuclear fission reactors. Overall, fusion energy technology has some potential to provide safe, clean, and sustainable source energy. Here are some additional considerations. Public acceptance. Fusion reactors are a new technology, and it is important to ensure that public is aware of the potential benefits and risks before they are deployed. Regulations. Fusion reactors will be needed to regulated to ensure that they are operated safely and that risk of accident is minimized.